Hey everyone, so I'm going to do a video on the unit circle to show you where all the points come on the unit circle. So again, this is on an XY coordinate plane. So that means that there is a distinct point on every piece of this circle. So the first one I'm going to analyze is 0 degrees, which is a point right here on the unit circle. Because it's a unit circle and we are on the x-axis, my point here is 1, 0. The next point I'm going to analyze is this point up here, and that is at 90 degrees, and that point will be 0, 1. Then I'm going to analyze 180 over here, and that is negative 1, 0, and then 270 down here, and that value is 0, negative 1. Those are the simple ones to find. Now what we're going to analyze is we're going to analyze the first quadrant, because that's actually going to help me find the rest of the quadrants. So what I want to find is this point, and this point. And we're actually going to use certain degree measurements here. The first special degree measurement is going to be 30 degrees. Then the next measurement is 45 degrees, and the next would be 60 degrees. These are 3 common angles that are used in the unit circle and that you will be seeing in trig. So the reason why they're most common is because they come from these 2 triangles over here, the 45-45 90 triangle and the 30-60 90 triangle. So I'm going to put my right angle here, so that represents my 90 degree. So the first thing I'm going to do is I'm going to do the 30-60 90 triangle. And the reason why is because I'm going to have to find this point here. And if you realize there is a triangle here, if you see it. So this baby angle here, that piece right there is 30 degrees. So what we're going to do is find the point that goes with it. The way that you're going to find the points are, well, you're going to use the idea that each point, x comma y, is cosine of theta comma sine of theta. So to get 30 degrees, what I have to do is look at my picture, and I want to do cosine first because that's my x coordinate. So cosine is adjacent over hypotenuse. So adjacent over hypotenuse. So radical 3 over 2. That is my first point here. So here in this circle, the x value is radical 3 over 2 because that was cosine from the triangle. To get my y value now, I'm going to go back to that triangle and look at 30 degrees again and do opposite over adjacent. Opposite over hypotenuse, I'm sorry, SOHCAHTOA. So sine would be opposite over hypotenuse. So 1 over 2 is your coordinate point for the y value of sine of 30. So 1 over 2. So that's your coordinate point here. Now what's cool is that that point will match up with other points in the other quadrants because you are using the same angle here. That distance is the same distance as this distance, and the same distance at that distance, and the same distance as this distance. So the angles that are here, here, and here will be equivalent to 30 degrees. So the way that I find that, well, I know this is 180, and I'm going up 30 degrees from 180. That would be 150 degrees, because 180 minus 30. The next one down here would be 180 plus 30. That would get me 210. And then down in the fourth quadrant, that would be 360 minus 330, because 360 is this line, and you're subtracting from 30. This is also 360, and that's 330. Now what's cool about this is that because you know it's radical 3 over 2 comma 1/2 over here, all they are is negative or positive over here. So because we're in the x-axis, over here is negative, I'm going to have a negative x value. So instead of positive radical 3 over 2, I'm going to be negative radical 3 over 2, and the y value is still positive, so positive 1/2. And then down here for 210, they're both negative because we're in the third quadrant. And then for the fourth quadrant, only the x is positive, and then the y is negative. So that's 30 degrees. All right. So now let's analyze 45 degrees. For 45 degrees, again, to get my x value, I'm going to have to do cosine. So here's 45, and you can use either of these angles. So 45 is adjacent over hypotenuse. Now this one's a little weird because adjacent over hypotenuse is going to give me 1 over radical 2. And we don't like that because there's a radical in the bottom. So I'm going to rationalize it by multiplying by radical 2 over radical 2, which will give me radical 2 over 2. Okay? And what's cool is that cosine is radical 2 over 2. So let me write that inside of my triangle. Well, my unit circle. So radical 2 over 2. And because it's an isosceles triangle, sine of this is also going to be opposite over hypotenuse. So cosine was adjacent over hypotenuse and sine was opposite over hypotenuse. It's still 1 over 2. So it's still going to be an answer of radical 2 over 2 for this thing. Okay. That means that there are also other angles in the other quadrants that have the same measurement. And those angles would be here, here, and here, because they are a distance from 45 degrees from the x-axis. So the value that represents 45 degrees in the second quadrant, well, I would have to do 180 minus 45 to go up 45 degrees. So 180 minus 45 would get me up 45 degrees. And that would get me a value of 135 degrees. And then I would do 145 plus, well, 180 plus 45 degrees to get my angle here, and that would be 225 degrees. And then I would do an angle on the fourth quadrant, which would be 315 degrees. And all of them would have a radical 2 over radical 2 over 2, comma radical 2 over 2 pattern. But again, like the 30-degree angle, negatives are going to come into play. So it's not going to be positive for the x, it's going to be negative, and then positive. And then the fourth quadrant, they're both going to be negative. And in the fourth quadrant, I think this is the third quadrant. And then in the fourth quadrant, we're going to have x be positive and y be negative, because you're in the downward direction of y. And the last one we're going to fill in is 60 degrees. Okay, so for 60 degrees, what we're going to do is look at our special right triangle and look at the angle of 60 degrees. Again, I'm going to do cosine first because that's my x-coordinate. So cosine's adjacent over hypotenuse. That's 1 over 2. And then my sine is my y value, and that is going to be opposite over hypotenuse. So radical 3 over 2. So that's this point here, 1/2 comma radical 3 over 2. And again, in all the other quadrants, it's going to be the same, but with different signs. The measurement that'll be here for 60 degrees will be 120, and the reason why is because it's 180 minus 60, and then 180 plus 60 in the other quadrant is going to be 240. All right, and then the last quadrant is going to be 300 degrees, because 360 is this distance. You want to go 60 below, so that's 300 degrees. All right, so for the second quadrant, x is going to be negative, so it'll be negative 1/2 comma radical 3 over 2. So negative 1/2 comma radical 3 over 2. And then this would be both negative, so negative 1/2 negative radical 3 over 2. And then in the fourth quadrant, only x is going to be positive, so positive 1/2 and negative radical 3 over 2. The only other thing I wanted to say about this is that in your calculator, obviously you're not going to have a unit circle on the regions, these radicals do mean something. So for example, when you type in like cosine of 30 degrees, you get 0.866, and you know from the unit circle that cosine of 30 degrees is radical 3 over 2. So that's why I've been telling you that radical 3 over 2 is 0.866. So whenever you see that, they mean radical 3 over 2. And the same thing if you were doing cosine of 45 in your calculator. Obviously you wouldn't see radical 2 over 2, you're going to see 0.707. If you look at the unit circle, we just figured out that cosine of 45 degrees would be radical 2 over 2. So that's why I told you that 0.707, just memorize that it's radical 2 over 2. Okay, I hope this video helped. I'll see you guys soon, and have a good night.